Tonight, billions of tiny beams could light up Earth in unison. But if every single phone flashlight turned on at the exact same moment, would we make the night vanish from space? In this video, we're going to find out. With over 6.8 billion smartphones in the world today, each equipped with its own tiny LED flashlight, we'll calculate how bright Earth would get if all of them turned on at once. Could it rival city lights, confuse satellites, or even make astronauts on the ISS? Do a double take? Let's run the numbers. And you might be surprised how much power we're carrying in our pockets. How many flashlights are we talking about? First, the count. The latest estimates put the number of active smartphones worldwide at around 6.8 billion. Some people own more than one, but let's simplify. Assume one flashlight per phone. That's billions of LEDs, all flicked on together. Example, if just one flashlight seems useless for lighting a street, imagine combining the entire population of Earth, and then doubling it. That's how many beams we're unleashing. Brightness of a single flashlight, a typical phone flashlight, has a luminous flux of about 40 to 50 lumens. That's roughly the brightness of a small candle or a weak light bulb. Not impressive by itself, but multiplied billions of times? Suddenly we're talking about a wall of light. Math breakdown. Let's take an average of 45 lumens per phone. Multiply by 6.8 billion phones, and you get about 3.06 times 10 lumens. That's 306 billion lumens total. What does that compare to? Okay, so what does 306 billion lumens mean in the real world? The entire city of New York at night glows at about 1.6 billion lumens, which means, for a few seconds, Earth smartphones would outshine New York by almost 200 times. Globally, that's like creating a new continent of light. Cue imagery. Earth from space, glowing with bright pinpricks. And then the phone flash continent switches on, like lightning frozen in place. Global. Distribution matters, but here's the catch. Not all flashlights are in one place. They're scattered across continents. Many point downward at the ground or indoors. Some won't be turned exactly upward. Light scatters. So instead of one massive spotlight into space, what we'd see is a patchwork glow, concentrated in cities where phone density is highest. Example, in downtown Tokyo, millions of beams would overlap, turning streets into something brighter than day. In rural deserts or oceans, darkness would still dominate. Would satellites see it? Now the big question, could satellites or astronauts in orbit see this sudden glow? Absolutely. Earth's night side already sparkles with artificial light, highways, factories, megacities. Add billions of LEDs, and satellites that track light pollution would definitely register a spike. To human eyes aboard the ISS, the difference would look like a global lightning storm frozen mid-flash. Not blinding, but unmistakable. Introduce a problem/challenge, but there's a twist. While the numbers look huge, does all that light really add up to something useful? Or would physics, scattering, distance, and atmosphere, quietly dim our mega flashlight before it reaches space? The atmosphere is a light filter. The atmosphere eats light. Even city lights lose more than half their glow before reaching orbit. With phone LEDs being relatively weak, a large fraction of their power would scatter sideways or downward. So while satellites would see the effect, the boost might be smaller than our raw numbers suggest. The blinding ground problem. Another issue. Most people don't hold their phones straight up. Lights spill onto the ground, walls, or even back into our faces. Meaning, much of our supposed 306 billion lumens doesn't escape into the sky. Cities would look dazzling from the ground, like every person holding a candle during a midnight vigil, but from space. The glow is more like a faint shimmer added to the usual light pollution map. Could we rival the moon? Here's a fun comparison. The full moon shines at about 1 lux on the ground, enough to read a book outdoors at night. If every flashlight beam was perfectly aligned upward, Earth's night side could reflect enough light to match or even exceed that. But with imperfect angles and scattering, we'd probably fall short. The moon would still win the brightness contest. The power demand, there's also the energy side. If every flashlight runs at around 1 watt of power, that's 6.8 billion watts or 6.8 gigawatts total. That's the output of about 7 nuclear power plants, all diverted into tiny LEDs. For one glorious moment, humanity would unify to burn a chunk of our grid on nothing but phone beams. So what's the final verdict? If every smartphone flashlight on Earth turned on at once, the night sky would shimmer with a sudden artificial glow. Satellites would register it instantly. Astronauts would notice a strange, ghostly shimmer across continents. But it wouldn't be bright enough to turn night into day, more like Earth breathing out a faint global sigh of light. A strange, beautiful flicker that proves how much hidden power we're carrying in our pockets. Every phone flashlight by itself is trivial, but together they rival the lighting of megacities, burn gigawatts of power, and leave a fingerprint visible from orbit. It wouldn't erase the night sky, but it would definitely put a temporary signature of humanity across the darkness of space. A reminder that sometimes billions of small lights can matter more than one big one.